Hello everyone. This video is about properties of logarithms. Since a logarithm is just an exponent, any property that we know about exponents apply for logarithm. Let's start with the first property, power property of logarithm. This property says, before I explain the property, we need to know that the base is always positive number other than 1, and number written next to log is also a positive number. P is any number, the power exponent of A is any number. So according to this property, if there is an exponent of the number written beside log, we can bring this exponent down in front, use it as a coefficient. So your new logarithm becomes p times log base b of a. No more exponents. Exponent becomes coefficient. Let's take a look at some examples. So the first example here, log base 10 of 10 to the power of 4. I have a power here. Let's just bring this exponent down in front. So 4 multiplied by log base 10 of 10. Log base 10 of 10 is 1. We learned this in the previous section. They have the same numbers here. Base and the number beside log are the same. They kind of cancel each other. So this is 1. 4 by 1 is 4. It is pretty simple. Let's look at the second one. We have an exponent here too. So let's pull this exponent down out in front. So it's 2 multiplied by log base 5 of 25. Okay, we got rid of the exponent, but we still couldn't simplify the logarithm. We have 25 here. We can write 25 in terms of 5. 2 by log base 5 of, in place of 25, I can write 5 squared, right? 5 squared is equivalent to 25. So now I see another power. Let's pull this exponent out in front to become a coefficient. So it becomes 2 by 2 by log base 5 of 5. Log base 5 of 5 will be 1. So here I have 2 by 2 by 1, which makes 4. Okay, the next one, I have an exponent. Similarly, move this exponent in front as a coefficient. So 5 multiplied by log base 2 of half. So the question is, in order to simplify this logarithm, can I write 1 over 2 in terms of the base? So this is the question. If I can, I will. If I can't, I will leave it as it is. Let's see if I can. Log base 2 of 1 over 2 is actually 2 to the power of negative 1. So I see another exponent here. So let's bring this exponent down in front. So 5 multiplied by negative 1 multiplied by log base 2 of 2. Log base 2 of 2 is 1. 5 multiplied by negative 1 is negative 5. So it's pretty simple. Let's go on, continue with the product property. The product property is similar to the product property in exponents. Remember, in exponents, if we are multiplying two numbers with different exponents, we keep the base and add the exponents. Since exponent means logarithm, in this property, when there is the product, we just rewrite the logarithm as sum of two logarithms, like adding the exponents. Adding the exponents in logarithm means adding the logarithms. Exponent refers logarithm, so we just add the logarithms when there is product. Log base b of m times n is log base b of m plus log base b of n. So we use this property to simplify logarithms. Write the logarithms uh, as a single logarithm. If there are two logarithms written in different logarithms, we can rewrite them as a single logarithm like this. Log base 3 of 10 plus log base 3 of 100, we can just multiply those numbers. Since the bases are same, multiply them, and we get a single logarithm. So this is a way of simplifying logarithms. So we see an addition here in the first example. I can rewrite this as a single logarithm first. So log base 5 of the first number is 625, second number is 25. We multiply them. Log base 5 of what is 625 multiplied by 25. 625 multiplied by 25. It is very large number. 15,625. Can I simplify this more? Is it a power of 5? Can I write this as a power of 5? I can. Okay, this is sixth power of 5. So I can move 6 out in front. So this becomes 6. The second one, 1 over 3 is the base. 1 over 3 is the base for the second logarithm. So I can keep the base as 1 over 3 and multiply the numbers. It's 27 multiplied by 1 over 9. I can do simplification here. 27 divided by 9 is 3. So log base 1 over 3 of 3. Can I write 3 in terms of 1 over 3? Actually, I can. It is log base 1 over 3 of 3 to the 1 over 3 to the power of negative 1. Right? 3 is equal to 1 over 3 to the negative 1. Now I have an exponent. When I move this exponent down in front, it's gonna be negative 1 multiplied by this logarithm, which gives you 1. 1 by negative 1, negative 1. Finally, I have a sum of 3 logarithms. The base is 10 since it is invisible. So I keep the base and multiply the numbers. 0.1 times 1 times 10, which gives us 1 only, right? 0.1 times 10 is 1. 1 times 1 is 1. So one of the properties that we learned in the previous section, no matter what our base is, if the number written next to log is 1, then the answer is 0. So the next property we're going to study is the quotient property. It is similar to the quotient property in exponents. Let's say we have two numbers, we are dividing them with this different exponents, then we keep the base and subtract the exponents. The same goes for logarithms. If there is division, we can subtract the exponents. Exponent means logarithm, so we can take the difference of the logarithms. We can also use this property to simplify logarithms, write them in a single logarithm. For example, we have log base 5 of 16 minus log base 5 of 2. We can simplify this as writing log base 5 of 16 over 2. But here, when we apply this, we have to be careful because order matters. First, we write the top, log base 5 of the numerator minus log base 5 of the denominator. For example, log base 7 of 49. So write this as a single logarithm. Log base 7 of 49 is the numerator over 7 is the denominator. So it's gonna be log base 7 of 49 over 7, 7, 7, 7. They cancel each other. It is 1. Same idea here for the next question. Write the base and divide the numbers. 32 divided by 128. So here I have log base 2 of 32 and 128 will simplify. It's gonna be 1 over 4. And the question is, can I turn 1 over 4 to 2? Can I write 1 over 4 in terms of 2? Let me try. So it's log base 2 of, I can write 1 over 4 as 2 to the power of negative 2, right? In order to flip the number, I should use a negative exponent. So 2 to the negative 2 is equivalent to 1 over 4. Here I see an exponent, negative 2. Pull it out in front. So it's negative 2 times 1, which is negative 2. We cover three properties. In the last two properties, we should careful about the common mistake here. Sometimes students are using the property in a wrong way. For example, log base a times b is not equal to log base a times log base b. It is equal to log base log base 10 of a plus log base 10 of b. We are supposed to add them. We are not multiplying them. Similarly, the other common mistake in the quotient property. When we have a quotient, it doesn't mean that we're going to divide logs separately. The correct way is log A minus log B, not division. So those are the correct rules. These are not. Be careful. So last two properties, inverse property. We already studied this in power property. When there is a power, we bring down the power in front, use it as a coefficient. So x is in front, x by log base b of b. Since log base b of b is 1, since the base and the number written beside log are the same, it is directly x. Similarly, if there is a base of exponent and the base of exponent is same as base of logarithm, they sort of cancel out each other, and you are left with x. So the questions are really simple. The first one here, the base is 10. There's an invisible base. Base and the number written beside log are the same. They cancel each other. We are left with 0.9. The second one, base of logarithm and base of the exponent are the same. They cancel each other. We are left with 8x. Here I have 7, 7, same bases. They will go. So 7 remains. 7, 7, they will cancel each other. 7 remains. 7 minus 7, 0. And finally, we have change of base formula. We apply this formula if when we don't have when we cannot calculate a logarithm. For example, some calculators don't have this button, log base something of something. This button is not available in all the calculators. So when we have such numbers, we can change the base into something that we already know, or something that we can do simplification by hand so that we can evaluate. How does this work? If we have log base b of x, for example, I can use x at the top, b at the bottom, and use any base that we want. So we divide the logarithms. One logarithm becomes division of two logarithms. For example, log base 4 of 8. I will write log 8 at the top, log 4 at the bottom. So whatever I want, I can use it as a base. For example, I can use 2 as a base because it's easier to evaluate. I know 8 is 2 cubed and 4 is 2 squared. So this becomes something I know. I have a power here, bring down the power in front. So it is 3 by log base 2 of 2, which will cancel each other. Here, log base 2 of 2 will also cancel each other. I will left with 2. So the result becomes 3 over 2. So by just changing the base, I can solve this by hand. For example, the first one, evaluate log base 9 of 27. I can't evaluate this by the calculator, but when I write this as log base 9 of 27 as log 27 over log 9, and I can use a base that I can evaluate by hand, like 3. 27 is multiple of 3, 9 is multiple of 3, so I can use 3 as a base. So it turns out to be log base 3 of 3 cubed. 27 is equal to 3 cubed over log base 3 of 9 is equivalent to 3 squared. So using the previous property, you have the same numbers here. They will cancel each other. These two will cancel each other. So I am left with 3 at the top, 2 at the bottom. 3 over 2, 1.5. So I can do this. For the questions that I cannot do this by hand, I can write this as a base of 10. Like write log base 10 of 27 divided by log base 10 of 9 log base 10 of 9. I have this button in the calculator. Everyone has this button in the calculator. Without the base, you can type this. Type log 27 into the calculator. It will give you an answer. Type log 9 into the calculator. It will give you an answer. When you divide them, you will get the same number.